This video is going to look at units and kind of why we care about them or why they're important in science. So a unit is a known quantity of something. So for example, if I said 1 apple, right? That's a known quantity of something. The apple tells me kind of how much stuff. So if I wanted to say that someone weighs 100 apples worth of weight, that means if you had 100 apples, then they're the same weight. And this is important in science because it allows us to compare results and ideas. If I'm doing all my measurements in meters and someone else is doing all their measurements in centimeters, if we just looked at numbers, those wouldn't match and we'd say we have different answers. But if we know that we're using different units, we can compare them. This is especially important kind of long term. Like if I want to use data from 100 years ago, I need to know what units they were using because I can't talk to them and ask them like how did they do it. I'm stuck with just looking at their measurements. So kind of looking at units, we have a couple major unit systems used globally. Well, primarily one with kind of a secondary. So SI, which comes from French, and it is the shorthand for metric. And this is the standard that we use in math and science. That's all we'll use this year is metric. It's used globally pretty much everywhere, except for you can see the kind of English or imperial units are used in the US, Liberia, and Myanmar. So quite a few places, most everywhere, we've got standardized to metric. When we're looking at units, we have fundamental units, which are the most basic ways to measure the universe. So there's 7 of these, and these can be used to measure all the basic things about the universe. Anything we want to measure will be either measured in these fundamental units, or it can be measured in these fundamental units, or it can be measured in some combination of these fundamental units. So the first one, we have length, which uses the kind of SI units, we use meters as the base unit. You've got mass, which we measure in kilograms in the SI unit system or the metric unit system. Time is measured in seconds. Electric current is measured in amperes, or sometimes you'll see amps. Temperature is measured in Kelvin. And then the amount of stuff is measured in moles. So like if you want to count how many of something exists, we use the unit of moles. And then finally, luminous intensity is candela. That's just brightness. So these 7 units can measure anything that you can think of. Any type of thing that we can put a number to is either could be measured directly in one of these or some combination of these. So that's where we get to this idea of derived units. So derived units combine those fundamental units and give us another measurement. So for example, you've got velocity, which is measured in meters per second. You've got density, which is measured in kilograms per meters cubed. You've got atomic mass, which is measured in kilograms per moles. Force, which we'll see as kilogram per meter per second squared. And the list goes on and on. So everything that we talk about in physics will have some sort of units that are either a fundamental unit or some combination of fundamental units known as a derived unit.